At Siemens, we believe that additive manufacturing allows companies to reimagine their products, reinvent their manufacturing, and even rethink how they do business. In the aerospace industry, there is an increasing emphasis on weight reduction in an effort to improve efficiency of aircraft. Over the years, aerospace manufacturers have used many methods to achieve lower vehicle weight goals, such as the use of cutting-edge materials like carbon fiber. One way to lower the weight of individual parts in an aircraft is through new technologies like topology optimization and additive manufacturing. Topology optimization takes inputs such as material type, build envelope, and load conditions, and allows the computer system to design an optimized part from those inputs. Since load conditions are used as an input to the topology optimization process, the system also calculates the distortion and strain on the optimized part resulting from the applied loads. This optimization, repeated over multiple parts throughout an aircraft, can result in a lower weight and therefore better efficiency. When spread across the years of aircraft service, this can result in large fuel and cost savings. However, topology optimization often creates parts that are difficult to manufacture using methods other than additive manufacturing. So Siemens NX contains functions for executing the entire additive manufacturing process, from design to print. This includes build tray setup, support structure generation, and print execution. For aerospace companies and suppliers, having the entire additive manufacturing process integrated into a single piece of software means that the digital data thread from design to print is unbroken and properly managed. This enables true traceability of the data from the beginning of the process to the end. At Siemens, we're working to industrialize additive manufacturing so that the aircraft we fly in the future will be as efficient as possible, reducing the carbon footprint from flights across the globe.